Now equation of continuity. Suppose here we have a steady flow of the fluid. Now in this particular steady flow, we consider 3 points P, Q and R. Now at point P, Q and R, consider the cross-sectional areas AP, AQ and AR. Now these cross-sectional areas AP, AQ and AR under consideration are such that the number of streamlines passing through each cross-section, that is the same one. Okay. Now suppose the velocity of the fluid at point P, that is Vp, at point Q, that is VQ, and at point R, that is VR. Okay. Now, if we think about the volume of the fluid passing through this cross section AP in small time interval delta t, then say the fluid which one is passing through this cross section with velocity Vp in time interval delta t, that will be accommodated in the tube having length equal to Vp into delta t. કારણ કે delta t ટાઈમમાં કેટલું ડિસ્ટન્સ કવર કરે જે પણ કોઈ ફ્લુઇડ આમાંથી પાસ થાય એ તો ડિસ્ટન્સ that is velocity into time. એટલે Vp into delta t જેટલું ડિસ્ટન્સ કવર કરે. તો આપણે એવું કહી શકાય કે Vp into delta t લેન્થની ટ્યુબની અંદર એટલું લિક્વિડ એકોમોડેટ થયેલું છે. So we can say the volume of that liquid, that is delta Vp, equal to cross-sectional area AP into Vp delta T. Okay. Now suppose we think about the mass of the fluid passing through this cross-section AP in time interval delta T. Now mass, that is volume into density, we already calculated the volume of the fluid passing through that cross section. So delta mp, that is mass, that is density into volume. So rho p ap vp delta t. Similarly, we can write the equation for the mass of the fluid passing through cross-section AQ in time interval delta t, that is delta mq equal to rho q aq vq delta t, and the mass of the fluid passing through the cross-section AR in the same time interval delta t, that is delta mr equal to rho r ar vr delta t. Now mass is constant one because fluid that we consider incompressible. So mass of the fluid passing through AP or AQ or AR in the same time interval, that is same one, or we can say the mass of the fluid passing through any cross section per unit time, which is also known as mass flux, that is constant one. So we can write delta mp equal to delta mq equal to delta mr. Now substitute these values. Rho p ap vp delta t, that is equal to rho q aq vq delta t, that is equal to rho r ar vr delta t. But density of the fluid, that is constant one. So here we can cancel rho p, rho q, rho r, as well as delta t, delta t, delta t. So we can write AP VP equal to AQ VQ equal to AR VR. હવે અહીંયા આપણે ત્રણ જ પોઈન્ટ પસંદ કર્યા. આવા આપણે ઘણા બધા પોઈન્ટ્સ લઈએ અને બધા પોઈન્ટ પાસે આવા ક્રોસ સેક્શનલ એરિયાસ કન્સિડર કરીએ તો આપણે આવી ઘણી બધી આઈડેન્ટિટીઝ અહીંયા લખી શકીએ. It implies that in general we can say when all these are equal means A into V, that is constant. Or we can write V proportional to 1 upon A. So this is called equation of continuity. Equation of continuity you can write that is AV equal to constant, or you can write V proportional to 1 upon A. Clear to all of you? This equation of continuity shows this thing. In the fluid flow, where the cross-sectional area is less, there the velocity will be more. And where the cross-sectional area is large, the velocity will be less. Clear?